Let's work on this stoichiometry problem together.
A scientist in an industry lab creates ammonia by reacting nitrogen gas with hydrogen gas. She takes 100 milliliters of nitrogen gas and reacts it with excess hydrogen gas. What is the mass of the ammonia that would form during this reaction? Nitrogen gas at standard temperature and pressure has a density of 1.215 grams per liter. Stoichiometry problems should always start with a balanced chemical reaction. Next, we should look at the problem and write down the key measurement that the answer will depend on. That means looking to see if we're dealing with a limiting reactant or not. So here, we have 100 milliliters of nitrogen gas, an excess hydrogen gas, which makes our life easy because we're going to be limited by our supply of nitrogen gas. So for step B, the key measurement that the answer is going to depend on is the amount of nitrogen gas that we're dealing with. Units are important. This isn't just a volume, it's a volume measured in milliliters. Next, we have to see our endpoint. What are we trying to get to? Here, we're asked, what is the mass of the ammonia that would form during this reaction? That means that we are interested in grams, the unit of mass that we're likely going to end up in, of ammonia. I already know that I'm not going to be dealing with kilograms or tons or something like that because we're given this density here of nitrogen gas in grams per liters. Grams is going to be the only unit of mass that we have to deal with in this problem. Now we write down all of the conversion factors we have to take through from the starting measurement all the way to the end. If we're starting with milliliters, we're going to eventually need to get to moles because moles of nitrogen and moles of ammonia are related in our equation. We can get the mole ratio. So we know we have to get there eventually. So we can start with our density, linking us from a volume and a mass. We have that molar ratio. We'll need that. We know that 1 mole of nitrogen gas will get us 2 moles of ammonia. Notice that I'm not concerned about hydrogen in this problem. It doesn't play a role because we have excess hydrogen. We'll also need a molar mass. If we end up with moles of ammonia, our final answer needs to be in grams of ammonia. Remember, you get your molar mass by looking on the periodic table. Ammonia has 3 hydrogens and 1 nitrogen, so we just add those up. We are also going to need the molar mass of nitrogen, and that is 28.01 grams per mole. By looking through our conversion factors, you can sort of see a pathway develop going from our starting point of volume. We'll have to get from milliliters to get to liters in order to get to grams of nitrogen. We have a way to go from grams of nitrogen to moles of nitrogen. We have our mole ratio to get us from moles of nitrogen to moles of ammonia. And we have a way from getting from moles of ammonia to grams of ammonia. So now comes the difficult part in writing out our factor label method or dimensional analysis to get us from our starting point to our end point. What I'm going to do now is write out that conversion factor chain, and then I'll walk you through what I'm doing in each step. All right, so it should make sense that I am starting with our key measurement, what we're given. It's the only number in the problem that we have. We have milliliters. Milliliters and a density of grams per liter means that we have to get it into liters. So this is where the conversion from milliliters to liters comes in. We're converting milliliters of nitrogen to liters of nitrogen. And that is because we need to get from liters to grams. So density is the way to get a certain volume and turn it into a mass. So here, since we know how many grams are in 1 liter, we take this amount of nitrogen and use density to convert volume to mass of nitrogen. So up until this point in our calculations, we would have mass of nitrogen. So all of this is conversions to get to mass of nitrogen. Then you can take the mass of nitrogen and you can go to moles of nitrogen. That is using the molar mass we know in 1 mole of nitrogen, we have 28.01 grams. So if we take the mass of nitrogen and divide it by the molar mass, we'll get the number of moles of nitrogen that we're dealing with. That's not what our final destination is. We're trying to get to ammonia. So up until this point, we have calculated the moles of nitrogen. Now you're ready for using the molar ratio to go from moles of a reactant to moles of a product. And you can see for every 1 mole of nitrogen you have, you make 2 moles of ammonia. So we would take the moles that we have here of nitrogen and simply multiply by 2 to figure out how many moles of ammonia we're dealing with. That is again not where we're ending things because we're asked to find the mass of ammonia. So here, last step, using the molar mass of ammonia, we can go from moles to mass. And you're saying, well, that is the opposite of what you did here, and that's why you can see a flip. We're multiplying by the mass, and here we were dividing by mass. So let's see that our units have canceled out. If we're dividing by 1,000, we can get liters of nitrogen. If we're multiplying by the density, we can get grams of nitrogen. Divide by the molar mass, get to moles of nitrogen. Get out of moles of nitrogen and into moles of ammonia. Multiply by the molar mass to get mass of ammonia. So our equation looks like it will work out. Our units will all cancel out. The last step is to use your calculator. So what I would do is multiply everything across first. That means we take 100, multiply it by 1.251, multiply it by 2, multiply that by 17.03, and then we're going to divide that by everything in the denominator. That means 1,000 times 28. Make sure you have parentheses here. Everything else is 1. So that is our answer. 0.1521. Most importantly, units, we end in grams of ammonia. The only unit that doesn't get canceled out here.